Hello students, I am Dr. Himlata Ganveer, Department of Applied Physics from Yashwantrao Chauhan College of Engineering, Nagpur. Today we are going to discuss about the ruby laser. So now you are able to see the cross-sectional view of a ruby laser. So herein you are observing some colorful picture of the ruby rod, a xenon flash lamp and a power supply and the entire assembly how it looks like. So let us now have the discussion of ruby laser. So friends, ruby belongs to the class of gems and it is a example of solid state laser. So this laser was developed by Sir T.H. Maiman and his team in the year 1960, and in this a synthetic ruby crystal, which is basically aluminum oxide doped with 0.05 percentage of chromium atoms, is used. So aluminum oxide is inert or a host material and chromium atoms are the active centers into them. The concentration of chromium atoms varies and the color of the ruby crystal changes. So the picture you are observing is a schematic diagram of a ruby laser in which the ruby crystal is taken in the form of a cylindrical rod having length 4 centimeters and diameter of around 0.5 centimeters. This rod is wounded by a helical xenon flash lamp connected with a high voltage power supply. The ends of the ruby crystal are grounded and polished with silver paste or the to constitute the two ends of optical resonator. And you are observing that the tube is having a coolant, so inlet and outlet is there to circulate the coolant, so that you can protect the crystal from the thermal damage. So we have got the construction part and let us go for the working of this. So this is the energy level diagram of the chromium atoms. So ruby laser utilizes the optical pumping as we have used the flash lamp, and it is also working on the principle of 3-level pumping scheme. So this picture is belonging to chromium atoms where there are 3 basic energy levels. The E1 is the grounded state, E2 is the metastable state, and E3 and E3 dash, they both are the absorption bands or the excited state. So the xenon flash lamp emits white flashes of light which are lasting for few milliseconds. Out of these white flashes, only blue and green components are absorbed by the chromium atoms and are taken to the absorption bands E3 and E3 dash. Now, these absorption bands are having a lifetime of the order 10 raised to minus 9 to 10 raised to minus 8 seconds. Hence, they are highly unstable. Therefore, the atoms undergo rapid decay process and come to the metastable state. So during this transition from E3 to E2, there is no photon emission and we call this as a non-radiative transition. Once the atoms are arriving at the metastable state, the lifetime of metastable state is pretty high, that is of the order of 10 raised to minus 6 to 10 raised to minus 3 seconds in comparison to the absorption bands. Therefore, atoms are trapped or accumulated at the metastable state. So the excitation process continues and more atoms are accumulating at the metastable state. So soon a stage is reached when more than half of the ground state atoms are available at the metastable state. So this is the condition of population inversion, where the upper energy level is more populated as compared to the ground state. Hence, a chance photon which is emitted from the metastable state triggers the stimulated emission, and a characteristic red photon of wavelength 6943 angstrom is emitted. This photon is continuously augmented between the two ends of the ruby rod and hence when the sufficient number of photons are there, a ruby light or the red light is emitted out of the ruby laser. So this light is emitted in the form of a pulses lasting for few microseconds, and this is how the ruby laser works. So just now as I told that ruby laser is giving you pulsating output, so this can be treated as the disadvantage of the ruby laser. So what are its disadvantages then? So xenon flash lamp lasts for few milliseconds and the laser does not operate throughout this particular period. Therefore, the metastable state gets depopulated very rapidly and the lasing action is not observed. Hence, the output of this laser is a discontinuous output. Okay, so discontinuous or a pulsating output is obtained. So this is the first disadvantage. Secondly, as we have to transport more than half of the ground state atom at the metastable state, so we will require a very high pumping power to for this purpose. And thirdly, out of the white flashes only the blue and green component is used by the chromium atoms or is absorbed by the chromium atoms. Hence the efficiency of ruby laser is less. So the first working laser, the ruby laser, with its disadvantages we have discussed. Thank you very much for listening.